Hi everyone, my name is Rafael Cruz and you are at the channel Cruz Espacial. Let's learn a little more about orbital dynamics and what the STK software or system toolkit developed by ANSYS. Okay, let's start. Our objective is brief introductions to orbital analysis, present the STK software, and present the certifications offered by ANSYS. Introduction to orbital analysis. In this slide, we have two books, and the first is Fundamentos de Tecnologia Espacial. Editor or publishing is Instituto Nacional de Pesquisas Espaciais, de São José dos Campos, 2001. Okay, and the second book is very important literature and about space missions analysis and design, or SMED, 30 editions, and your publisher is Space Technology Library. And for introductions to orbital analysis and the other exercise, we have the principles and segments for the missions. And in this case, we see the first is ground segment. And in this case, we talk stations for controller and space vehicles and antennas for telecommunications in the systems, whatever for transmitter or receiver. Okay, the second segment is a launch segment. In this case, we talk rockets in January. Okay, in totally our full rocket, 20% is about payload. In the case and satellites, and approximately 18% is propellant for the moving this vehicle. Okay, in the 30 segment, it's normally space segment. In this case, we talk satellites, but have two hovers. Okay, named Popularity and Robots in the other's body. For example, Moon or Mars. Okay, and it's very important. Different types of orbits, and the principal orbit for missions and the Earth is a Leo orbit. Okay, Leo orbit for generally satellites, small satellites, and actually it's talk for CubeSats or PocketSats, okay? And we have two medium Earth orbit or MEO and GEO or geostationary Earth orbit or two geosynchronous synchronous orbit. And these two orbit, GEO and MEO, is more utility for system positions, regional or global. Okay. Other parameters for studying dynamics orbital, it's ephemeris. And for example, this orbit is not circular, it's an ellipsis. And AG and eccentricity is not zero, okay? And the center for this point, we have a perigee, and the center of the principal body, in this case the Earth. At this point, we have an apogee, and less distance or short distance, and in this point we have a maximum distance for the vehicle space in comparison of principal body. In this case is Earth. Perfect. Is the simple form it is. We have two semi-major or axis of the ellipse, semi-minor axis of the ellipsis, and the polar angle of the ellipsis, radius of apogee, radius of perigee. Okay. Next, and we have a system coordinate for the vehicle space. In topic A, we have a spacecraft fixed coordinate in 3 axes, and the first is X, okay, in epsilon and Z. And Z it's nadir for this example, but is not a rule, okay? In the next figure, we have a Greenwich meridian or Earth fixed coordinate, okay? And two, in this case, we have a rho, pitch, and yaw, RP epsilon coordinate. And we have two celestial coordinates. In this case, an axis X. It's a vernal equinox direction. Okay. Is the figure imply or full. Other topic, it's very important, it's a coverage axis for the satellite. And in this case, we have many types of sensors. Okay. And example 1, RA. And we have axis for the coverage, and in these ellipses we have a footprint, okay, and in this line we have a trajectory for the satellite, for example. Perfect. In top KB, We have a different Doppler, and the lambda 1 is different, or different the lambda 2, okay? And the different is a Doppler shift. Perfect. In this line, we have a trajectory for the craft or satellite generate, okay? And in this case, we have a synthetic aperture radar. In this case, 2, okay? SAR, synthetic aperture radar. And in this area, we have a line area of access in this satellite. We pair this sensor is a area and the big area, okay? In this case, it's less area for access. Introduction to STK or System Toolkit for analysis and dynamics orbital and others categories. And ANSYS Inc. is a developer of engineering simulate software. Okay, Computer Aided Engineering or CAA, based in Canonsburg, Pennsylvania, United States. The company was founded in 1970 by John A. Swanson and originally named Swanson Analysis Systems Inc. And is a comparative for STK and ODTK. In this software, the foundation for the analysis and visualization complex systems in the context of their missions. But this software, ODTK, it's Orbital Determination Toolkit, process tracking data and generate orbital ephemeris with realistic covariance. Okay, but we focus in this STK only. Perfect. And the software STK is digital mission and engineering software provides a physics-based simulation environment for your mission's needs. Okay? And do you need a simulate for aircraft or satellite or rocket launch or car or diversity vehicles? Okay? Do you 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 can to simulate in the STK. Your system and component models can interaction in the STK application enable you to measure their perfect in the context of the complete mission. This approach software supports collaboration with distributed multidisciplinary teams across all your operation domains and life cycle phase. And about certifications, STK have a training, the level 1, level 2, and level 3. Okay. And what study at level 1? I resume for you. In level 1 beginners tutorials, you study build scenarios, objects and properties, access reports and graphs, moves and visual data files, introduction to connectors, and properly test or exam for STK level 1. And this example build scenarios, objects and properties, access report and graphs. moving visual data files, introductions to connectivity. And STK level 2, do you study using terrain, changing constellations, customize analysis with analysis workbench, and computer coverage over regions. Introductions to the azimuth elevation mask tool and volumetrics, and 2. Introductions to radar signal. And the STK Level 3 focus tutorials is feature specifics or problem specifics. Repair this study it's more long, okay? Can you dedicate more time? And we have different scenarios. For example, introduction to STK, water, SATCOM in mountain and steering, okay? ANSYS 8FSS and STK for communications and radar analysis, introduction to communications graphics, and the others. Oh, I selected these examples: introductions to modeling propagation laws in an urban environment, introductions to radio frequency interference analysis, SATCOM mountain steering, and again ANSYS 8FSS and STK for communications in radar analysis, and introductions to the STK synthetic aperture radar capability. In the second case, problem specific, and we have many scenarios again. Oh my god, excuse me. For example, modeling GPS positions accuracy using coverage is very important for analysis or GDOP or HDOP, and with correlative and geometric and dilutions of positions and the others, okay? And create a multi-hop communication linking, STK radio frequency or RF spectrum filters, carrier to noisy radio in the LEO, MEO, and GEO zones, GPS receptions and interference, radar tracking and jamming, aviator VTOL and terrain following, introductions to satellite maneuver, planning with astrogator, analyze potential satellite conjunctions, and evaluate ATF communications links. And basically, we are outputs for the STK for category signals communications. We have a link budget, signal to noise ratio, bit error rate, shift interference analysis, access durations, communications coverage maps, and the signal radar, and we have a receiver part, radar cross sections, grazing angle, slant range, look angle or incident angle, revisit time, radar footprint, time delay, interference active or passive, and the others. Okay, and we can to make integrations in the other softwares. It's not necessarily requires for ANSYS development. For example, in this example, we have ANSYS developed for the spectral analysis with the integration at the STK. Okay, repair. We have a scenario for a space segment and your analysis spectrum for the correlations at the gain of the communications or link budgets. And in this slide, we have demonstrations for the development at STK and Mission Digital Engineering or MDA. Okay, these are very important because our requires is a development and the of form and iterate, okay, and but if we talk to MBSA or model-based systems engineering, and we have requires and fix it, okay, and basically MBSA we have a fixes requires define it and very important, but MDA or mission digital engineers our requires is flexibles, but we we our and and we need to and we need to validation systems, okay, okay, and in this case and it's very interesting because STK is the development for the ANSYS, but MATLAB is the develop for the math works, and we we can to integrate MATLAB with STK. Okay, it's very important for develop for many works, and the interface is communications, and the protocol is TCP/IP. Perfect. And in the finally, we can to integrate STK with and the connection between ANSYS STK and National Instrument Solutions. Okay, where STK provides the platform, motions, kinematics, payload, models, and other environment impacts that contribute to forming a realistic simulated radio frequency RF link. This provides an executive simulation loop where engineers can design and test their RF systems through both software in the loop (SIL) and hardware in the loop (ATIL) strategies. Okay, these two solutions integrate is the big solutions for your work and your solutions in the industry, academy, and others. Conclusion and integration of the loan project in a realistic 3D environment, accurate evaluations of coverage and access windows with STK. This is reference